So kind of for our final question here on looking at, applied word problems, we're going to go ahead and take a look at one of them that involves kind of like a trajectory of something. So Melinda and Genevieve are living in houses that are next to each other. Melinda lives in a two-story house, and Genevieve lives in a bungalow, so one-story. They like to throw a tennis ball to each other through open windows. The height of the tennis ball is thrown from Melinda to Genevieve in feet over time, and x in feet, and then over time x measured in seconds, and have a function here. So kind of like a quick picture, kind of got two-story house here. It's a great house. And we got like a one-story house over here. It's a great picture. And we're going to have somebody throwing a tennis ball from this one to this one. And that's kind of like what the picture kind of looks like. And that's sort of what our parabola is going to look like as well. We have our function kind of listed for us. This function could easily have been given in a different way. This function could have easily been given something like height is a function of time equals -5t squared plus 6t plus 12. And in fact, I would get used to seeing functions like this and then having to use that into Desmos. So we have what are the domain and range of the function if Genevieve catch the ball 4 feet above the ground. Draw your diagram to support your answer. So let's go ahead and let's put this into Desmos. Just like we do, we're going to use y and x. So they give it to us in function notation f of x, but we're just going to use y. Y equals -5x squared plus 6x plus 12. So let's kind of tweak our graph just a little bit here. I think I'm going to increase it a little bit. And you know what? I think I'm just going to go from, let's see. Let's try out -2. I like what our max x coordinate was, so that's okay with me. Let's see what else we can do. We can kind of slim down this one as well. So we can go -2 to 5. Let's see what that brings us. This is pretty good, I think. Yeah. Let's get a couple things from our graph that we'd like to look at. So I'm just going to kind of go ahead and just talk a little bit before I put this into my work. If x is trying to represent time, then we wouldn't ever have any negative x's, right? This is our negative time, which really wouldn't make too much sense. And if y is representing the height of the tennis ball in feet, then we wouldn't have any negatives either. So this would be a good question for us just to kind of take a look at. X has to be greater than or equal to 0. And that's our time. And then our y. And that's our height. So I think this might be looking a little bit better for us. And you know what? We might just be able to cut down our x's just a little bit further. Let's go to this and let's go to 3. And I think now our parabola might look a lot nicer. Definitely. Let's put down some coordinates that might be interesting for us. And let's go ahead and put this into our work now. Here we go. So copy that over either by hand or by using your computer and just looking at it like this. And we kind of have this function. So what we're actually looking at is our tennis ball's height as a function of time. So our x-axis down here, and we're going to do this by hand now, but our x-axis is actually going to be time. And the question says that it's measured in seconds. So time, t, measured in seconds. And this is going to be our height. We're using the variable, I think I'll just use the variable h. I'm going to label it like this. This would be like the grade 12 type of question being used. So I think I'm just going to change it into this. This is h, and this is measured in feet. So I just changed it to be kind of a grade 12 question here. So what are the domain and range of this function? If Genevieve catches the ball at 4 feet above the ground. Well, we have a problem here. This shows the path as if this house doesn't exist. This shows the path of the tennis ball coming from Melinda's house and hitting the ground. That's what this was, right? And it's going to take 2.261 seconds to hit the ground. But we have a problem here because Genevieve lives in the bungalow and she's actually going to catch it before it hits the ground. That kind of makes sense. So she's going to catch it at 4 feet above the ground. This is where you're going to need to make a decision. Is this a vertical line at 4, and that would be an x equals 4 case, or is this a horizontal line? And the key is, what is the unit they give you? They're giving you feet, which is a y-axis variable. They're not giving you time. So if they're giving you 4 feet above the ground, then that is your indication that you need to make something that's going to go along the vertical axis. Or, yeah, something that will go along the vertical axis, aka that horizontal line. You could think of it as parallel to the horizontal axis. It's kind of that flip-flop. So we need to go back into Desmos, and we need to make another line. Back into Desmos, and we need to make a horizontal line, y equals 4. And this is going to represent when Genevieve, I think Genevieve is going to get the ball. So let's go ahead and let's just click on that point. We know it's at 2, 4. Let's go back to our graph here. You can either include it in your graph or we can just draw it in by hand. I'm just going to choose to draw it in by hand. So we have this coordinate here, and this is at 2, 4. So for our work here, we would just say y equals 4. That's our line. We would say we're going to intersect, and we would get 2, 4. This is the time of ball being caught. So our problem only lies between when the ball is launched and when it's caught. All of this stuff afterwards doesn't actually exist in our problem. Now, we wouldn't actually have to disinclude this, like we wouldn't have to not include this in the problem, because this could indeed happen. And they're not saying draw a diagram of this situation, nor in grade 12 would they want you to. They would be happy with this, and then you can do the analysis of it. But for the domain on this question, we have to take this into account. So our domain, time, is going to start at 0. I'm going to use the variable t, like you would in grade 12. And it's going to stop when Genevieve catches the ball at 2. It's not going to stop at 2.26 because that's when the ball would theoretically anyways hit the ground if Genevieve didn't catch it. My range is going to go from lowest to biggest. So if Genevieve caught the ball at 4 meters, this is my height. So again, using the variables that would be expected of you in grade 12. The maximum height is from our vertex, 13.8. A lot of stuff going on in the question, and it causes a lot of, do you know what you're looking at? Can you analyze it in a certain way to get what you're looking at? So just make sure that you can, if you need to, draw a picture of it, but really be able to manipulate Desmos in order to get the picture of what's going on. And then do your intersections of a vertical line or a horizontal line, depending on what's given. And that would close our lesson down.